All right, this is our new 3D printer, and we're using it in our new engineering course where we're learning to both program and to work on simple electronic circuits. We have a bat signal, which basically you can take your phone, put a light through it, shine it, you've got the bat signal come up. We've been practicing on this print. We didn't like our initial results. First one we printed looked a little messy on the bottom, so we decided let's go ahead and do an experiment. We're going to try to print without printing on a grid, because initially it also printed on this grid, and that's what caused the lines. Second print we did, we eliminated our grid and we printed just on the bed, but the bed's heated and it had a little tendency to melt. Next thing we did was we tried printing on the bed at a lower temperature. This one came out great. We just did a partial build to see what would happen. So right now we're right in the middle of trying to figure out how to get an optimal build. All right, this is from our build yesterday, and wow, did this come out so much nicer than another build that we did. This was our Ralph Lauren phone cover, but it has a lot of issues. It's not only our build, but other people had issues with it as well. But you can see that it has a lot of lines across it. So we did another cleaner build without using that platform, and it came out really nice. Now, last night, folks, I was looking up how can we make this smoother, and we can actually set up an acetone vapor that will just eat away very little bit. It puts a shiny gloss on it, and I think that will look really cool with your phone. So I do. I'm going to take it home this weekend and see if we can do acetone to it. So today, let's do another build. First, see how it works on the phone.
I was expecting it to be pretty good.
Oh, that's really cool.
Yeah.
That's way better than I thought it would be. That's nice. All right, that was from a succession of experiments we did. We logged down our data. We noted all of the changes that we made. We made changes in extruder temperature, platform temperature, and we noted all of those. And this was the results, and I'm pretty happy with that. We'll try the acetone to get it really smooth and glossy. We'll see how that works. What do you folks want to print today?
Downloaded another Batman theme to Battleground.
I should not be surprised, another Batman theme. All right, let's do it.
Okay. All right, what we're doing right now, when you first get a program off of the Thingiverse, it comes in a zip file. This is the file we want, just Batarang. And we found to change the bed temperature, we have to go into the G code. And up here near the top, we want to look for HBP temperature. We're making sure the extruders are clear, since as we get it heated up, we have to pay attention to that. The filament starts to melt as soon as it gets to temperature, and if you leave it as it is, then it'll come out and mess up the print. So we're going to go ahead and start building now.
So this is the filament that we're using, which is going through these tubes right here. And basically the computer is telling the filament to print out on the heating plate to 220 degrees. And so it creates the pattern.
The number one goal here is to figure out, in engineering, things go wrong, and you need to think on your feet how to solve those, you know.
I say we can use the 3D models. We can design our own by the CAD software. CAD is mostly free, and many people use that in college levels.
I think we can definitely use it as a fundraiser. People are generally interested in what we're doing, and we could definitely sell the products.
All right, second half of the class consists of Arduino microprocessor boards, and students basically get a board that has a microprocessor on it and a breadboard, and you go through and you build simple electronic circuits. This circuit, for example, consists of a button, a buzzer, and LEDs, and students have to write a code to go through. You press the button, lights the LEDs in a particular pattern, and it sounds the buzzer at the same time. They're all simplistic, but it does a really good job of teaching students just the basics of electronics. So we did a lot of projects with that last year as well. And this is the second half of the class, which is also the time that typically we utilize the 3D printer. First half is Python programming, second half is electronics, including 3D printer.
This build right here is an example of something we haven't had much in our other prints. It's using the infill setting. We've had that run on our very first prints, but none of the others. Essentially, infill is an automatic coding by the computer that takes a percentage of the build and supplies infrastructure on the inside to make it sturdier. That runs anywhere from, this one's running on 10%, so it's essentially a thin scaffolding structure, to 85%, which would be a more waffle-like structure. And it covers this up. You won't see it once the print is done, but it's on the inside providing the actual support. And it's a very handy function on the computer's part.